Hello there everyone, welcome to Edupedia World 9th Grade Computer Applications video lecture series. I'm Upeka Vendibona, and from this episode we are talking about another object orientation principle, inheritance. What if we could write a code that someone else could easily extend it, flexible for last-minute spec changes? Remember the episode we used to tell you the difference between object-oriented programming and procedural programming. In there, at the end, we came across a design something like this thanks to the inheritance. In that episode, we talked everything about flexibility and extensibility and how object orientation supports that. So it's better if you can watch that episode and come back in here. If I do a quick revise on how we arrive at this final design, at the first step, we looked at what all four classes have in common, and there we identified they are all shapes and they are all rotate and play sound. And in the second step, we abstracted out the common features and put them into a new class called shape. In the third step, we linked the other four shape classes to the new shape class in a relationship called inheritance. So in here we read this as square inherits from shape, circle inherits from shape, and so on. And then we remove the rotate and play sound methods from the other shape classes. So now on, there are only one copy to maintain. The shape class is the superclass of other four classes, and the other four are the subclasses of the shape. The subclasses inherits the methods of the superclass. In other words, if the shape class has the functionality, then the subclasses automatically get the same functionality. If you can remember, at the last minute we got a spec change in the amoeba class. It got totally different rotate method and a play sound method. So how can amoeba do something different if it inherits its functionality from the shape class? So at the last step for that problem, the amoeba class overrides the methods of the shape class, the rotate method and the play sound method of the superclass shape. Overriding means that a subclass redefines one of its inherited methods when it needs to change or extend the behavior of that method. So then at the runtime, the Java virtual machine knows exactly which rotate method to run when someone tells the amoeba to rotate. And that's how we arrive with this final design. Now I guess you have the basic understanding of the inheritance concept. When you design with inheritance, you put common code in a class and then tell other more specific classes that the common, more abstract class is their superclass. So then when one class inherits from another, that means the subclass inherits from the superclass. In Java, for that we say the subclass extends the superclass. Now this inheritance relationship, it means that the subclass inherits the members of the superclass. When we say members of a class, we mean instance variables and the methods. For example, if triangle is a subclass of shape class, the triangle class automatically inherits the instance variables and methods common to all the shapes, including perimeter, area, calculate the perimeter, and so on. And also, the triangle subclass can add new methods and instance variables of its own, and it can override the methods it inherits from the superclass shape. Now remember, there is no such a thing as overriding instance variables. We can only override methods because instance variables don't define any special behavior to override. So the subclass can give the inherited instance variable any value it chooses. Now look at this example design. It got three classes, the doctor class, surgeon class, and the family doctor class. The doctor class is the superclass, and under that there are two subclasses, the surgeon class and the family doctor class. Both the surgeon and the family doctor inherits the methods and instance variables from the superclass doctor. Now the doctor class got one instance variable, works at hospital, and one method, treat patient. Now the subclass surgeon overrides the treat patient method and got own method called make incision. And now the subclass family doctor has one instance variable, makes house calls, and a one new method, give advice. Now here are my questions. How many instance variables does the surgeon have? You cannot see any instance variables in the surgeon class, but it inherits the instance variable works at hospital from the doctor class. Therefore, the answer is 1. Now the second question, how many instance variables does the family doctor have? Now in the family doctor class you can see there is a one instance variable, and also it inherits the work at hospital instance variable from the doctor class. Therefore, the answer is 2. Now the third question, how many methods does doctor have? There is one method in the doctor class, treat patient. So the answer is 1. The fourth question, how many methods does surgeon have? Now in the surgeon class, it overrides the treat patient method and also it have its own method, make incision. Therefore, the answer is 2. The next question is, how many methods does family doctor have? In the family doctor class, it has its own method, give advice, and also it inherits the method, treat patient from the doctor class. Therefore, the answer is 2. The next question is, can a family doctor do treat patient? The answer is yes, he can, because family doctor is a subclass of doctor class and it can inherit the treat patient method. Now the last question is, can a family doctor do make incision? Well, in here, surgeon and family doctor are two separate classes. There is no relationship between them. Therefore, family doctor cannot do make incision. If we want to implement this design into a Java code, this is how we can do it. We have to first start from the superclass, the doctor class. Inside the doctor class, we have our instance variable, works at hospital, which is a Boolean type variable, and the method, treat patient. And now for the subclasses. Let's start with the family doctor. In the class definition, we have to mention that this class is a subclass of the doctor class. For that, we have to use the keyword extends. So in the class definition, we say family doctor extends doctor. Inside the family doctor class, we have to declare our instance variable make house calls, which is a Boolean type variable, and also the method give advice. And the next subclass, surgeon class, and also in here we have to mention surgeon is extends from the doctor, and inside the surgeon class, here we override the treat patient method and also add our new method, make incision. Okay, now look at the treat patient method in the doctor class. Here we are saying all about how to treat a patient by performing a checkup. But when we override this treat patient method through the surgeon class, we are saying all about how to treat a patient by performing a surgery. Now, if we call the treat patient method through a family doctor, he will perform a checkup, but when we call the treat patient method through a surgeon, he will perform a surgery. So that is how the overriding is happening. Now take a look at this example. Here we got three classes, animal class, canine class, and the wolf class. Now the canine class is a subclass of the animal class, but a superclass of the wolf class. The animal class got 4 methods, make noise, eat, sleep, and roam, and the canine class overrides the roam method, and the wolf class overrides the make noise and eat methods. Now due to the inheritance, the wolf class got 4 methods, one inherited from the animal class, which is the sleep method, and one inherited from the canine class, which is the overridden roam method, and 2 methods that wolf had override itself. Now when you create a wolf object and assign it to a variable, you can use the dot operator on that reference variable to invoke all of the 4 methods. But which version of those methods get called? This illustration over here depicts that. When you call a method on an object reference, you are calling the most specific version of the method for that object type. In the other words, the lowest one wins. Lowest meaning the lowest on the inheritance tree. For example, canine is lower than animal and wolf is lower than canine. So invoking a method on a reference to a wolf object means the JVM starts looking first in the wolf class. If the JVM doesn't find a version of the method in the wolf class, it starts walking back up the inheritance hierarchy until it finds a match. Now let's call the make noise method from the wolf object. So it first looks for the wolf class and there it finds make noise method. And then we take the roam method. It first look at the wolf class and there is no overridden method as roam. Therefore, it go up in the hierarchy and find out the roam method has overridden in the canine class. So this statement calls the version in canine. Now the next statement, it calls the eat method. It look for the wolf class and there it finds the eat method and it calls the version of the wolf. And in the next statement it calls the sleep method and it first look for the wolf class. There is no sleep method in it. And then it look for the canine class. There is no sleep method in it also. And then it look for the animal class and there you find the sleep method. So it calls the version in the animal class. And that's all what we got here in this episode. From this episode we covered up almost all the basic stuff about the inheritance, how to incorporate the inheritance concept into our design by creating superclasses and subclasses, and how to implement that design into Java code. From the next episode we are going beyond than that, trying to identify the inheritance relationship among classes. So stay tuned on and thank you for watching. This video brought to you by edupediaworld.com. Watch more from our website.